So with that, I'm going to give you guys a quick introduction to our awesome panel of speakers today, who you can see on the video feed over there. So this is going in order of speakers, right? So first off, we have Matt Robbins. So Matt is United States Navy Business Development Rep for us here at Transhield. So Matt goes coast to coast, visiting Navy ships, helping them fit covers on their vital equipment assets, making sure that everything on their ship is protected and mission ready. And what a not much better guy to do that. Matt's a 26-year Navy veteran with 6 major deployments, including Operation Desert Storm and Operation Iraqi Freedom. Matt finished his naval career. You can imagine in 26 years he had a lot of job titles, but finished his Navy career as the Senior Enlisted Combat Systems and Weapons Department Representative. So we're lucky to have him on our team, and we're lucky to have him with us today. He's got a lot of great experience with anti-corrosion covers, and he knows the value that these covers bring. Matt, how are you?
Great, Josh. Great, Josh. Glad to be here.
Next, we have Dave Sharman. So Dave is a military and technical advisor for Transhield. Dave is sort of our in-house subject matter expert. He's authored and presented numerous technical papers on the subject of anti-corrosion covers at defense conferences, both internationally and domestically. He's a member of the National Association for Corrosion Engineers and the Society for Protective Coatings. Like I said, he's our subject matter expert. Since 2015, Dave's primary responsibility has been researching another really interesting topic that hopefully we can cover in another webinar, solutions for the electromagnetic spectrum. So we're lucky to have Dave on our team and happy to have him here on this panel today. Dave, how are you?
Well, thank you.
Good. All right, and last and certainly not least, we have Jeff Bold. So Jeff is the Vice President of Government Business Development here at Transhield. His primary responsibility is serving the government market, specifically the Department of Defense. And Jeff has quite an impressive resume himself. He was a 30-year Marine Corps veteran and retired as a colonel in the Marine Corps Reserve. So, Jeff, how are you?
I'm doing well, Josh, and thank you, everybody, for joining us today.
Absolutely. All right, guys, I'm almost done talking, I promise. I'm just going to give you guys a quick overview of the presentation that we'll be covering today. So these first 4 boxes you see here, Matt will be covering, Mr. Robbins. So he's going to start by covering the cost of corrosion in the United States Navy. I'm sure you guys saw in that in the marketing collateral that we've been sending out, that number. It's a huge figure. It's really incredible. Then Matt's going to get into the Navy's strategy in the past and up until this point for combating corrosion. Then he's going to get into the use of anti-corrosion covers in the Navy. And then finally, he's going to get into what really is one of the main points of this presentation is the return on investment of anti-corrosion covers. You know, are they worth the hassle? Are they worth the money that they cost? Is there a return? Matt will cover that. Then he's going to pass it off to Dave, who's going to talk about the anatomy of covers. And then Dave will get into a real-world assessment that was done in 2015. It was a 30-day trial on board a ship and shows the effectiveness of these covers. And then finally, Jeff will bring us home with a conclusion, and time permitting, we will answer your questions then. So with that, enough from me. I will pass it over to Matt and let him talk about the cost of corrosion. Matt?
All right, thanks, Josh. Hello, everyone. So I'd like to start off talking about the cost of corrosion, but really quick, Josh touched on it, and I spent 26 years in the Navy, and since I've been with Transhield for about 6 years. Really loved what I did in the Navy, and now I'm glad to be able to kind of give back and help them out with solutions for corrosion. And I enjoy my job here at Transhield in designing and implementing these solutions and getting them out to the sailors that really need this help. So let's start off talking about the cost of corrosion. The LMI research firm was commissioned to conduct some studies on the annual cost of corrosion for DoD, and their findings came up with about $20.9 billion annually of the DoD's maintenance budget was spent on battling corrosion. And we see here on this slide that Navy ships About 19% of their budget, or $3.1 billion, spent just solely on corrosion. And Navy and Marine Corps Aviation, about $2.6 billion, roughly 26%. And then the Army ground vehicles coming up a little behind, around 10.5%, but $1.8 billion of their maintenance budget. So in September 2012, the Department of the Navy documented their strategy for corrosion prevention and control, and it's outlined in this publication. And throughout this, they talk about it, but anti-corrosion covers were outlined as one of the mitigating measures to combat corrosion. And it actually works really well for Navy ships. So to kind of give a background on covers, when I first joined the Navy in 1989, we used to use materials like Herculite and vinyl, and the sew shops would just sew up a basic cover, and it would get put over a piece of equipment more or less just to hide the rust or hide the corrosion, but it wasn't really doing a lot to combat it. And so and Jeff will talk about it a little more down the road, but as the covers developed and we came out with anti-corrosion covers, we're actually able to combat corrosion using these covers. So in 2013, Naval Sea Systems Command approved anti-corrosion covers, which were lightweight, form-fitting, and had VCI technology to combat that corrosion. You're going to find these covers on almost every class of the Navy ships. A lot of the Coast Guard ships are using them, and we have several different foreign navies and militaries that are using these things around the world as well. So for the United States, we have national stock numbers assigned to a good majority of these covers, and it makes it really easy for our sailors to go in and order the covers they need and outfit their ships with them. So in naval use, like I said, traditionally we used to use just kind of a plastic cover to hide the corrosion, and as the anti-corrosion covers evolved, we've come up with a lot better product, I guess, solution to combat the corrosion. And here we're seeing that certain pieces of equipment, if the covers are used properly, it's going to be ready when the sailors need that equipment to operate, whether it's a normal evolution or if it's in a wartime situation or what have you. If for whatever reason the equipment's not functioning due to corrosion, whether it's an outside mechanism is rusted shut or internally some components get corroded and wire connections maybe causing a short or a ground or something like that, and the equipment's not functional, it can cause a lot of problems with the ships. So we've found over the years the use of these anti-corrosion covers have been extremely helpful. So on this slide we see a couple of different covers here. On the bottom left corner, we're looking at an interior voice communication system jack box. And on the naval ships, these will be located all over the outside of the ship in different evolution areas. And they're used so the sailor can put a headphone on, plug that headphone into this connection box, and communicate through the various different stations on the ship, like the bridge, the combat information center, the engineering spaces, and the like. So communication is very important. And throughout time, they found that the connections on these jack boxes, because they're located kind of down towards the deck of the ship or in outside spaces, they get highly corroded, and when the sailors would go to plug their headphones in, they would have bad or no communications. So that was a problem, and a very simple form-fitting anti-corrosion cover placed over this jack box helps to prevent that corrosion situation from happening. And on the right lower side, we see one of the most popular anti-corrosion covers we have out there for the surface ships. It's a king post sliding pad eye cover, and I'm going to show in the next slide kind of how this piece of gear operates, but it's a electromechanical piece of equipment, very large on the ship. I think they're about 15 feet tall. And it's got a motor and gear mechanisms that connect a span wire between two ships when they're operating in close proximity to transfer stores and supplies and ammunition and the like back and forth with each other while they're out at sea. So when these evolutions are happening, the sailors would be connected into the IVEX jackbox, communicating back and forth between the stations for safety and to kind of talk about how the progress of the evolution is going. So they're completely different systems, but work in conjunction with each other. But if this king post sliding pad eye were to become corroded, the electromechanical mechanisms, they're not going to be able to connect that span wire, and it may cause a situation where the ship would have to go into port maybe to get the stores that it needs instead of being able to conduct operations at sea. So it's really important for the Navy to keep these things functioning at all times. You never know when the ship's going to need ammunition or supplies or food, and this piece of gear does that for the ship. So moving on, this is a picture that kind of shows that evolution. You can see the span wires connected between these two ships at sea. And during this evolution, they operate within about 300 feet of each other. So if you can imagine the ships being roughly 500 feet long, they're operating in about 300 feet of each other. One little minor course change or mishap could cause the two ships to collide. So the folks that are doing the evolutions, talking back and forth on those IVEX jackboxes, are helping to coordinate some of this and determine what the distance is and if the ship needs to steer course out or in or whatever it might be. Without those communications, again, we could have a lot of problems. They've had mishaps at sea where two ships collided, and a lot of the times they find out that's either a failed piece of equipment operating or a miscommunication. So again, just these pieces of equipment, the little IVEX jackboxes, super important for the ships, and keeping the corrosion off of them is really important for all their evolutions. So another piece of gear we find on almost every naval ship is a 50 cal machine gun mount. And here you see the Mark 93 50 cal machine gun mount, and just recently they came out with the M2A1 50 cal machine gun mount. These guns have been highly effective for the Navy in anti-surface warfare when you might have an inbound attack or something like that. Keeping the mechanical mechanisms of the gun operating properly is hugely important. And because, again, the location of this equipment on the ship, where it's taking salt spray and sea spray a lot of the time when the ships are underway and they're operating in very corrosive environments, it can cause a lot of corrosion on this gun, where the sailors are having to perform daily, if not twice a day, maintenance sometimes. And you can imagine if the gun's not operating, when the ship goes to defend itself, it could have a big problem with maybe an inbound surface target. So I like to think about this and use the USS Cole as a reference. In September 12, 2000, the USS Cole was bombed while it was sitting in port in Yemen. And that bombing caused a catastrophic loss of life and major damage to the ship. If they were using a 50 cal machine gun to defend the ship, which really wasn't the case at the time, but if that was needed and it wasn't operational, again, you're going to end up in all that catastrophic loss. So because of the Cole bombing, it actually became very apparent to the Navy that, hey, we need to have these guns functioning, operational, mounted while we're in port and at sea for the protection of the ship, and we need to keep them operating. So here we see that the form-fitted anti-corrosion cover on the 50 cal mount keeps it clean and protected, keeps it corrosion-free, and it's very quick and simple to remove the cover, install the ammunition into the gun, and have the gun ready to go in just a matter of seconds. So another great performing cover out there in the fleet. On this particular slide, another piece of self-defense gear for the ship is the Mark 38 gun weapon system. And we will see a lot of these protected with anti-corrosion covers in the fleet. It's a very intricate electromechanical piece of gear. And it's susceptible to a lot of corrosion and technical issues because of the corrosion. So as Josh said in the intro, kind of the latter part of my career, I was the leading weapons and combat systems department representative for a destroyer squadron out of San Diego. And we had deployed on 2 occasions with the Carrier Strike Group operating in Southeast Asia, as well as the Arabian Gulf and the Gulf of Oman. And during that time in the battle group, me kind of being in charge of all the weapons departments on about 18 different cruisers and destroyers, we started to notice that there were a lot of failures with this gun weapon system, and it wasn't operational when it needed to be. And one of the big things that was happening is they were getting corrosion on the battery and the battery terminals, and it wasn't allowing the gun to operate in the automatic mode. So the strike group commander commissioned myself and a few other members on some of the ships to kind of team together, outline what the problems were, and then come up with a solution. So as we did our research for about a month's worth of time, we found that the location of the gun mounts on the ships was being affected by helicopter rotor wash during underway replenishment evolutions, as well as just the corrosive environment at sea. And components inside the gun and with the battery terminals were being highly affected by that corrosion. So we determined that in conjunction with a daily freshwater washdown while we were operating in those environments and keeping the gun mount covered when it was not in use prevented that corrosion from happening. So kind of a win for that deployment situation. And pretty much ever since then, if you go around the Navy and you see one of these gun mounts sitting on a ship, most of the time you're going to see it protected with an anti-corrosion cover. Here, one last piece of gear we'll talk about again, super important for the self-defense of the ship. And I only have a chance to talk about a few of them, and they all kind of happen to be weapons. But there are many, many, many pieces of equipment on the ship that operate and can be protected by these covers. So here we're just kind of looking at the Seawasbravo cover, and it protects the mechanical and some of the electronic components on this weapon system. The Seawas is hugely important for the ships. It's kind of the last line of defense against an inbound aircraft or missile attack. And if it wasn't operating, the ship might take a missile hit, which could cause loss of life, major damage to the ship, and even possibly sink a ship. So very important piece of gear. And again, we see almost every time you have a really important piece of gear with the Navy, it's going to be protected by an anti-corrosion cover. Okay, let's talk about the return on investment. So the Army was experiencing reduced readiness rates and increased corrective maintenance actions. So the McGinley report took a look at that to determine what the return on investment of covers might be. And in their research, they took the assumptions of a Stryker vehicle service life of about 20 years and the cover's effective life of about 2 years, and the fact that the vehicle's operating in a corrosivity level of about C3. And we're going to see a chart here in a minute that shows that. So with all those assumptions taken into consideration, their conclusions were the return on investment could be as high as about 19 to 1, and that covers were almost always effective. I'm going to show that here in a chart so we can see why. On this particular chart from the McGinley report, it kind of breaks out the return on investment. So we see that our baseline being at 0, and the CHP storage space is a controlled humidity preservation storage space. So they're extremely expensive. If you look in the second column on this table, you'll see that a new CHP storage space has the most expensive cost of all the different storage or corrosion prevention issues they're looking at here. And that the cost of a anti-corrosion cover, 0.5 versus 750, much cheaper or less expensive. So if they had to build a CHP storage space, the military, number one, they have to find a place to build it, and that's kind of hard to do. Most of our military real estate's already been consumed. If they had an existing space and then they go to use it, they're going to have a pretty high return on investment. But again, most of that existing space is already being used. So, and if they had to lease it out, again, your return on investment's now gone down to one to one. So we see that covers are at a 0.5 for the purchase cost, but their return on investment is 19 to 1. General purpose warehouses, again, they kind of have a high cost. Very hard to find one that's not being used right now to store equipment in. And the return on investment is kind of down there low. And I'll show on the next slide where that relates to with a Stryker vehicle. So the McGinley report outlined this. Covers are almost always effective in preventing corrosion, and you get a really high return on investment. And the other good thing to note is that for the military, and especially with the Navy, it's hard to put a ship in a building. So covers are very effective. And for the ground forces and the Marines and the like, it's really hard to take a building on deployment. So again, covers are really, really effective. On this chart, we'll take a look at the Stryker cover because that's what was assumed in the McGinley report. And this is figure 1 from the McGinley report. And the Stryker covers roughly about a $3,200 price tag. And it has a roughly 3 to 1 return on investment based on the covers lasting 2 years. So as we go up on the scale and we look at a 50 cal machine gun, it has a 11 to 1 return on investment in that 2-year lifespan. So what the McGinley report, it really doesn't outline in this chart well, but if they took into consideration that a cover lasts 2 years, most of the covers last 2 to 4 years. So as we get higher in years, you get a better return on investment. And we've seen covers, some equipment covers in Barstow, California that have lasted more than 6 years on equipment. So most of the time we're seeing that 2 to 4 year cover life. And a little while ago I talked about the corrosive environments. And again, this is information that was taken into consideration in the McGinley report. We see that most of the areas that the Navy and the military operate in are in a C3 corrosivity area. But then you start to look at the fleet concentration areas and then the areas where we're doing actual deployments and operations. And we see that C3 elevate most of the time to a C4 or C5 corrosivity area. So as that corrosivity area goes up, your return on investment goes up. And with that, I am going to turn it over to Dr. David Sharma.
Thanks, Matt. Oh, good piece of information. So we wanted to talk about anti-corrosion covers with VCI and sort of how they work. So there are 3 fundamental lines of defense for an anti-corrosion cover. First of all, it blocks out dirt, dust, and UV rays. UV rays are important. A lot of people get caught up with just corrosion of metals, but there's degradation of elastomers, gaskets, tires as well. The second thing that the line of defense, our covers are, anti-corrosion covers are waterproof, but they also have a neat capability of allowing water vapor to permeate from beneath the cover to the outside. And the third line of defense is VCI's vapor corrosion inhibitors are embedded in the cover. As Matt mentioned before, the lifespan of anti-corrosion covers is generally longer than the 2 years in the McGinley report, and he rightly points out the return on investment is going to be higher. The Navy uses the Armadillo covers, and they're heavy duty yet lightweight and easy to use. They have a soft, inert, hydrophobic fibre that protects glass and chemical agent resistant coatings. So we're trying to do no harm while we protect the asset. So VCIs are an elegant solution to prevent corrosion. So a VCI in vapor form. Vapor corrosion inhibitor comes out of the cover and is attracted to the metal and lands on the metal and forms a barrier that prevents moisture getting to the metal, which basically interrupts the formation of corrosion. A couple of neat things about vapor corrosion inhibitors. As a general rule of thumb, as the temperature beneath the cover goes up or wherever you're deployed, the corrosion rate of corrosion will go up. But we also have an increased emission of vapor corrosion inhibitors. So we have a self-regulating system, and we also have a system that is self-healing. So if a sailor walked beside a cover that was on and brushed it, yeah, the vapor corrosion inhibitors are going to be brushed off the bare metal, but then they're going to be attracted back to it. So it's self-healing, self-regulating, and it forms a barrier between moisture and the metal, preventing corrosion. Back in 2015, a USAPAC and the 25th Infantry Division requested Transhield to support an assessment of covers, and we provided two types of covers, an XT anti-corrosion cover on a Humvee and a Armadillo anti-corrosion cover on an MEP 1040 generator. They were loaded onto the well deck of the Harold A. Klinger, it's seen in the picture, and were then transported from Malaysia to Hawaii on a 35-day trip. Sounds a bit like Gilligan's Island by a factor of 12. Now, the good thing about having the US Army involved in this, they were there at the start when we set up the experiment. They were there at the end. They witnessed everything that was going on. So we have a record of what actually worked. So you're seeing on the left the generator covered by Armadillo anti-corrosion cover, on the right the Humvee, and we've got some signs on there to basically say experiment in progress. And we've used corrosion coupons, so Q-panel Type S low carbon steel coupons, uncoated, to hang inside and outside the covers. And more often than not, we used paired coupons. So we'll use some UV resistant latex or UV resistant thread to tie a coupon that's hanging outside the cover and one just inside the cover. So we have a local understanding of how the corrosion's working near where we put the coupon beneath and outside. And we had a hobo data logger to measure temperature and humidity beneath the covers as well. And the post-exposure, if you look at the photographs on the top row on both of those, the metal coupons are unsurprisingly rusted, like they're totally rusted. And the paired coupons inside have a little trace bits of corrosion on them, but holding up pretty well. And that's after, remember, 35 days in a well deck on a ship going from Malaysia to Hawaii. And when you start looking at it in a little bit more detail, and rather than focusing on corrosion, and we like to talk about do we protect an asset? Because Matt's talking about protecting critical combat systems and topside equipment so that they're functional when the Navy needs them. So we don't really want to talk about corrosion. We want to talk about how much does it protect your asset? Are you ready to go when required? So if we look at ASTM D610, which is an optical way of evaluating corrosion, we've taken that a little bit further and scanned the photographs, which are taken right at the end of the 35-day trip, witnessed by the US Army, and look at the amount of pixels of corrosion and uncorrosion and come up with a percentage of how much is protected, how much uncorroded versus the total number of pixels. And you're seeing on the left-hand side, we've got more than 98% protection on the generator, and outside there's no cover, no protection. And the Humvee ambulance, we're a little bit higher number. Now, obviously, they're really fantastic results, but we'll show you all of the coupons that we did and the numbers vary somewhat depending on location, but still significant amount of asset protection compared to a coupon that is outside. And in all honesty, on one of those ones on the Humvee ambulance, we actually managed to lose a coupon, and we document that as well. So the key takeaway on this is that the covers, anti-corrosion covers work. The combination of 3 lines of defense, protection against UV, protection against water, ability for moisture to permeate outside the cover, and then the vapor corrosion inhibitors deliver a cover that will protect your equipment, making sure it's ready. So first of all, it drives down maintenance costs, but also it ensures when your equipment is needed, perhaps in the South China Sea, it's ready to go. And with that, it's back over to Jeff.
Thank you, Dave. So a little bit about the company we represent. We're Transhield Incorporated. We're out of Elkhart, Indiana. We're a company that's been involved in the mitigation of environmental damage and anti-corrosion for over 25 years. We kind of started with the OEM marine industry, focused on keeping things from being damaged in high-speed shipping and in storage, and over time that's evolved into a wide variety of anti-corrosion and protective cover solutions to a broad range of industries, including very high-tech industries such as modern HVAC, wind energy, and aviation. And in fact, the bottom right-hand picture you see on this slide is just a sample example of some of the covers we provide to hundreds of aircraft for Boeing. Our R&D experience is very strong and has resulted in the awarding of 13 patents to date. And most recently, and Josh mentioned it earlier, we now have a partnership with the Navy Surface Warfare Center, Port Hueneme, California division for the development of products that can mitigate interference in the electromagnetic spectrum. Specifically in the support of the DoD, we've developed a strong cadre of professionals, including retired senior officers like myself, retired senior staff non-commissioned officers like Matt, and other people like Dr. Sharman, who understand the challenges and needs of the modern military when it comes to anti-corrosion and maintenance. As a result, we have widespread acceptance across all services and widespread use of our products across all services. Approvals have been given to our product by program managers, equipment specialists, ISEAs, and even large organizations like Matt Robbins mentioned earlier, the Naval Sea Systems Command. We mentioned a couple of tests and evaluations that have been conducted today, but literally over the last 15 to 20 years, there have been dozens and dozens and dozens of evaluations and testing conducted on our technologies by most branches of the military and even by some multinational companies we service in our industrial vertical. As a result, we have an ever-growing number of national stock numbers, and I can't remember if Matt or Dave mentioned that before, but if you've ever had to purchase or buy anything from the military while you've been in the military or involved with the military, it's extremely difficult, but a national stock number, it makes it the easiest possible route to procure something that a commanding officer or an end user needs to properly maintain and manage his equipment. On a personal note, I was an artillery officer in the Marine Corps for most of my 30 years, and around the year 2000, I visited a Civil War museum, and they had a great section on cannons used in the Civil War. And I went over and spent quite a bit of time there, to my wife's annoyance. But I looked at the tools that the cannoneers were given back then to maintain their cannons, and with just minor changes, they looked exactly like these same sorts of tools and crocus cloth and things like that we were using nearly 150 years later in a very time-consuming, maintenance-intensive environment such as artillery. And a couple of years later, I was introduced to to earlier versions of this technology, and it got wide-scale acceptance in the Marine Corps and then other services pretty rapidly, and it's been a real honor for me to be able to be involved in this and to see the effect, the positive effect it's had on the ability to do maintenance and the time savings it's given the sailors, soldiers, and Marines as they go out and do all the good work that they do for us in the world. Just to wrap up, if there's an item or component that you need to protect from the environment or somebody you know needs to protect from the environment, our team can always find a solution, just about always find a solution. And we normally come on site at no cost to you, and we work out with you the best way to protect your equipment. If we cannot find a solution in that rare occasion, we continue to work with you to find the best alternate way to do that. And I guess with that, I will turn it back over to Josh, and thank you very much for your time today.
Thanks, Jeff. Yeah, and thank you. Thank you once again, everyone, for attending, and thank you to our presenters. Awesome job, all of you. We're going to go ahead and get into your questions in just a second here. But before I do that, I just wanted to pause on this screen real quick. If you guys have any questions for these guys after this presentation, Matt, Dave, or Jeff, here is their contact info. Feel free to reach out to them directly via phone, however you see fit. So we've got a few questions here that we will get into. This question's from Dave. David, what is
Josh, that's
CST?
that's off
Now,
table one from the
slide he's
McGinley
referring
report.
to.
I've got that one.
Does anyone know?
So the T is a corrosion service team. So
Okay.
when we were talking about the differences in storage buildings and the like to prevent corrosion, they looked at corrosion service teams as well, and that's a maintenance contractor that would be deployed to provide preventative and corrective corrosion maintenance to a piece of equipment. I hope that helps.
Great. Okay, next question is from, good. I think that's a good answer. Next question: do you have a corrosivity? I think that's what it means. Corrosivity data for HOA and European theater of operations. Do we, guys?
Yeah.
I guess I can probably handle it. I'm not familiar with HOA, but we have done some work in the European theater of operations with a couple of companies over there, and we are providing covers for some of the militaries and companies over there, and they've been evaluated, and they tend to keep buying, so they appear to be working. That individual can contact me directly if they'd like, and we can go more in depth on that.
He clarified, Jeff, HOA means Horn of Africa.
Oh, Horn of Africa?
Do we have any data?
Not exactly Horn of Africa, but we have data for similar environments all over the world. Kuwait, the U.S. desert has similar environments as the Horn of Africa. Yeah, so this works well in that type of humid desert environment.
Josh, just from a deployment experience, we normally have a destroyer or two operating in the vicinity of the Horn of Africa, and they're using anti-corrosion covers on a regular basis out there.
Okay, great. I think this question leads in nicely to that. Let me see here. What factors make up a corrosive area? I think this is in reference to the map, Matt, that we had pulled up. What factors factor in?
Generally, I think they're looking at the heat, the humidity, the amount of rainfall. Those kind of things make up the corrosive factors that we're looking at on that chart.
I'll add informally in the military community, we've kind of used something called the rule of sevens, and basically, or the rule of 70s, basically if you're within 70 miles of a large body of salt water, like an ocean, if the temperature is above 70 degrees or you experience humidities above 70, you're going to get corrosion. You're in a corrosive environment. And if you get multiples of those, obviously it gets even more corrosive. So think of Norfolk, Virginia in the summer. That's extremely corrosive. So.
Interesting. Okay, and then I think this question would probably be for Matt. How long do the covers need to be
actually, Dave kind of spoke about this, but if you already have corrosion on a piece of equipment and then you put the cover on it, the cover's not going to make that corrosion go away. But as soon as you put the cover on, the VCIs start activating. So you're providing protection immediately when you put the cover on. And then Dave did discuss this, I believe, but if you take the cover off, the VCIs kind of trickle away, and then as soon as you put it back on again, they come right back.
So it's probably best for that cover.
Well, that's how most of our units are operating. Right? They'll cover their equipment until it's needed. If they had evolution on a particular day, they're going to go take that cover off probably several hours before an evolution occurred. And then once it's done, they're going to go and put the cover back on to protect their equipment.
Now, this is the last question. How long do these covers normally take to install?
That's a great question.
Something for you.
Depending on the complexity of the cover design and the equipment. We try really hard to get the sailors involved when we do the design for the naval ships and the Coast Guard, and to get their feedback on how they want it to be used, how easy it is to use. We like to get a cover on and off with just in seconds or minutes, really. But there are some other complicated covers, like we looked at the example of the King Post sliding pad-eye cover. It's 15 feet tall. It takes 3 or 4 sailors to get it put on the ship. They've got to do a little bit of hoisting, and a sailor has to get in a harness and go up a ladder that he's connected to in a harness to fasten that cover all the way down. So that might take 30 minutes or more, just depending on how everyone's working together. But in the example of the 50 cal machine gun, you can put that cover on in less than a minute. So it's very quick to get on and very quick and easy to take off.
Great. And then Christopher asked a question. We have a few more here. Christopher asked a question. Chris, I don't think we can answer this. He's asking who should be targeted when selling to Navy ships. Maybe take that offline with Matt Robbins. I'm not sure if we want to answer that on here. Christopher, maybe ask Matt that. Maybe shoot Matt an email and see if he wants to disclose that. I don't know if he wants to share his secret. 2 more questions. 2 more questions here. Are these covers stitched or heat sealed? Can the covers operate in negative 40 degrees Celsius to plus 50 degrees Celsius? I can repeat that.
Jeff, unless you want to, I think I can
have an idea?
take this one.
Yeah, I can start with this one. It depends on the material, not the material, but the technology we're using. Our XT covers can be welded, so that's heat sealing. Our armadillo covers are stitched. Now we have a specialized, what we call our military stitch, that makes this stitching as close to waterproof as you can get on the armadillo covers. In terms of the cold, I'm sorry it escapes me what we've been tested down to in our chamber, but our covers have been used quite a bit north of the Arctic Circle with no problems. Now, when it gets that cold, truthfully, you don't have a corrosion issue. So you have worse issues. You have ice issues and freeze issues and things like that. So if you'd like the exact specifications, they may be on our website. If not, contact me and I will get you the max temperature that we've tested each of our technologies down to. Thank you.
Oh, you know what, Jeff Sechkin, who's our head of R&D here, just chimed in, and he said armadillo can be used at negative 45 degrees Celsius. XT cover, which is our different cover material, can be used at negative 60 degrees Celsius. But to the asker of that question, still feel free to reach out to Jeff if you'd like more information, and he can connect you with it. All right, I think one more question here from David. Is there some defined system to determine the cover life? Just visual? Question mark. So is it just when you know the cover's done, you can see it, or is there some kind of standard life cycle? I think is what he's asking, or is it just on a visual basis?
Matt, I can take the first answer at that. Again, it depends on the technology, but for example, with an XT cover, which is a polyethylene base, you will start seeing the cover start to flake. What breaks down our covers at the end of the day usually is the UV rays, and after about 2 to 4 years on an XT cover, you'll start seeing it begin to flake, depending on where you have it, depending on the temperature, things like that. There's multiple factors that affect the life of a cover, depending on how often you take it on and off and use it, and things like that. So that's what you'll see on an XT cover. On an armadillo cover, the type used primarily by the Navy, again, you'll see deep fading, and then you'll start to see the fabric start to thin and break apart. We're doing extensive testing on the lifespan of our VCIs now, and we have yet to find a cover that has started to fall apart in which the VCIs are not still providing very solid anti-corrosion protection.
All right. Fantastic. Well, that is all the questions that we have. Once again, I popped our presenter's information up here once again. If you guys have any follow-up questions, again, you will be getting a recording of this presentation along with the PowerPoint. So, but again, don't hesitate to reach out to one of these guys if you have additional questions. Thank you to our presenters, Matt, Jeff, Dave. Thank you guys. Thank you to the audience that joined. We appreciate you guys sharing some time with us. Looks like we're going to give you guys back about 5 minutes in your day. But thank you all for joining us. Guys, any last remarks before we get out of here?
Thank you, everybody.
Thanks.
Good. All right.
Thank you.
All right, everyone. Thank you.